Alright, in this video we'll take a look at finding the magnitude and direction angle from component form and vice versa, finding component form from magnitude and direction angle. So if we place a vector in the coordinate plane, we can put the initial point at the origin as we saw and the terminal point at the same coordinates as the horizontal and vertical components of our vector. So here we have it in the first quadrant. Looks a lot like the XYR right triangle that we've talked in great detail about from trig functions of any angle. And again, here's that section again. So when I said it's probably the most important section of the entire course, I wasn't kidding you. Um, so from trig functions of any angle or from polar coordinates, uh, instead of x equals r cosine theta, it's x equals the magnitude of our vector in place of r, same thing though, times the cosine of theta, and y equals the magnitude of our vector times sine of theta, or y equals r sine theta. I guess really it's just more applications of trig functions of any angle. So if we look at our components, we have v cosine theta, or magnitude of our vector cosine theta for our horizontal component, magnitude of our vector sine theta for our vertical component. We can actually factor these out so we don't have to write them twice. So if we factor it out of the vector, we have the magnitude times the cosine of theta sine theta. So just factoring it out. And all right, example 5. Find the component form of a vector where the magnitude is 5 and it's in quadrant 2. It makes a 60-degree angle with the negative x-axis. So our magnitude is 5 and it's in quadrant 2, but it makes a 60-degree angle with the negative x-axis. In other words, it's a 60-degree reference angle with the negative x-axis and it's in quadrant 2. So if the angle makes a 60-degree angle with the negative x-axis in quadrant 2, then the total amount we would have rotated to get that terminal side is 180 minus 60, or 120 degrees. So the 60 degrees here is just a reference angle, but again, sometimes it might give you a y-axis, so be careful with that. Helps to sketch the picture. So our vector is, our magnitude is 5, and we have cosine 120, sine 120. Well, we have those exact values in our chart. So we have negative 1/2 for cosine of 120 and radical 3/2 for the sine of 120. And if we distribute the 5 to both terms, 5 times negative 1/2 and 5 times the square root of 3/2, we get negative 5/2 for the horizontal component and 5 square root of 3/2 for the vertical component. All right, example 6, we're just going to work backwards. We have a vector, 3 and negative 3 radical 3. We're going to find the magnitude and the direction, or the angle rotated, and we're going to keep it between 0 and 2 pi, very much like we've done a lot of the problems in the past, and we'll write it in this form. So our magnitude, Pythagorean theorem, 3 squared plus, we can ignore the negative out in front, but please make sure that the 3 square root of 3 goes inside parentheses, because we have to square both the 3 and the square root of 3. When we do that, we get 9 plus 9 times 3 is 27, so 9 plus 27 is 36, and the square root of 36 is 6. So our magnitude of our vector is 6. And then if we look at using reference angles again, the inverse tangent of the absolute value of negative 3 square root of 3 divided by 3 will give us, this will be negative square root of 3, and then take the absolute value of that. If we take the inverse tangent of square root of 3, we get pi over 3, or 60 degrees. Well, our angle, or our vector rather, has a positive horizontal component, positive x, and a negative vertical component, or negative y. So positive x and negative y, this is actually going to end up in the fourth quadrant. So if we put a 60-degree reference angle in the fourth quadrant, that means we would have rotated 300 degrees, or 5 pi over 3 radians, to get there. So we could work with degrees, that's fine, or we could work with radians, it really doesn't matter. But the total angle rotated to get from 0, or from the x-axis to negative 3 radical 3 is 300 degrees, or 5 pi over 3, which now we can write it, the magnitude is 6, and cosine phi pi over 3 sine phi pi over 3. And that about does it for this video, and we are done with the notes for this section. We'll see you in the next video on dot product.